Hello viewers, welcome to my channel. This is Skyborn Educational Consultant. We are going to solve a question on physics, which is the diameter of two planets are in the ratio of 4 to 1. Their mean densities are in the ratio of 1 to 2. The ratio of their acceleration due to gravity on the planet is. Now, for us to find this, we have G equals to Gm over R squared, where your G is your universal gravitational constant, your M is your mass, and your R is your radius. So if we want to take note of this mass, we know that in the question we are not given mass, but we are given diameter and densities. Then we need to relate this formula back to in form of the expressions of densities and diameters, where your mass, which is m, equals to density, which is written as rho, times volume, which is written as v. Your density is given, but your volume is not given. But volume is equal to what? Is equal to 4 over 3 pi r cube. For the first planet, your volume of the first planet, which is V1, is equal to 4 over 3 pi r1 cube. And the volume of the second planet, which is V2, is given as 4 over 3 pi r2 cube. Now, if we take the ratio of the volumes, we have V1 over V2 to be equal to what? 4 over 3 pi r1 cube over 4 over 3 pi r2 cube. Where 4 over 3 pi can cancel 4 over 3 pi to remain r1 cube over r2 cube. That means v1 over v2 is equal to r1 cube over r2 cube. So we've related volume in the form of radius. This is your radius, your r is your radius here. So, but in the question we are given diameter, and diameter, which is d, is equal to 2 times the radius. Let me rule this. So that is your diameter for the first one, for the first planet, over your diameter for the second planet is equal to 2 times radius for the first planet all over 2 times radius of the second planet. Where 2 can cancel 2. That means the ratio of your diameter is just r1 over r2. So that means we've made our radius in the form of diameter. Now that is r1 over r2 is equal to d1 over d2, or r1 ratio r2 is equal to d1 ratio d2. Then we cannot see, by going back to this equation, how we have that the ratio of g1 over g2 is equal to g, which is constant for all planets, times m. all over r square. That means r1 square. All divided by what? The one for g2, which is g m2 all over r2 square. That is g1 over g2 is now equal to, since we know that for our m1, that means row 1 times v1, that will be for our m1. And what's row 1? Okay, don't let us input the value now. Row 1 and v1. Note here, since universal gravitational constant is the same, g cancel g. Therefore, row 1 times v1 all over r1 square will remain, divided by row 2 times v2 all over r2 square. That means g1 over g2 is now equal to, what is v1? Row 1, instead of writing v1, we now write, instead of writing v1, you now write r1 cube, because your v1 is r1 cube all over r1 square, all divided by row 2 times r2 cube. That means your v2 is your r2 cube divided by r2 square. So therefore, if r1 square cancel r1 cube, it will remain 1 r1. And if your r2 square here cancel r2 cube, it will remain r2. Okay, so therefore your g1 over g2 is now broken down to row 1 r1 all over row 2 r2. Then your g1 over g2 is equal to, now what's row 1? Row 1 is the density for the first one, which is 1, times what's your r1? That means your r1 is equivalent to your d1, which is 4, divided by what's your row 2, which is the density of the second one, is 2, times your r2 is what? Is your d2, which is 1. That means your diameter 2, which is 1, times 1. So g1 over g2 is now equal to 1 times 4 is 4 all over 2 times 1 is what? 2. That means your g1 over g2 is equal to, what is 4 over 2? 2 over 1. That means your g1 ratio g2 is equal to 2 ratio 1. That is the solution, final solution for the question. Final answer. Thank you for watching my channel.